Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to get an introduction to probability. So let's go ahead and get started. So we're going to base everything off the example of a dice. So I'm going to try to draw my dice here. This is a traditional die with 6 sides, nothing fancy here. And so there we go, there's our 6 sides. And so when we're talking about probability, we're talking about the likelihood that something is going to happen. But I need to break down some terms for you. So every time you roll the dice, this is an example of what they like to call an experiment in probability, because this is something you can observe and see. So you roll the dice, that's an experiment, because you want to experience whatever the result is, if I had to be a little bit more technical. Now, you also know that on a dice, you have 6 different numbers, 1 to 6. And these right here are the outcomes. These are the numbers on the actual dice. And when we add up all the possible outcomes, we have something called the sample space. So all outcomes, when you add those up, or when you think about them, you call your sample space. So to see if I can make things a little bit more clear, you can say the number 2 is an outcome, but the numbers 1 through 6 is the sample space. It is all of the potential outcomes. While the number 2 is one outcome, numbers 1 through 6 represent all possible outcomes and is also the sample space, if you will. Now, events is another term we have to understand, and that is when you take a subset of the sample space. So, subset, okay, hold on, event, here we go. So you got a subset of the sample space. Now, what does that mean? A subset is when you don't take all the possible outcomes, but you take one or more of the possible outcomes. For example, I might want to know, odds, or I might want to know evens. In other words, I'm taking a subset of all the sample space. So for the odds, it would only be 2, 4, 6. These are the numbers that are my events, or it might be 1, 3, 5. Whoops, did it backwards. So for the odds, it would be 1, 3, 5, as you already know. And then for the evens, it would be 2, 4, 6. These are examples of events, of an event. It's a subset of the sample space. Now, when we're talking about probability, like I already mentioned, it is the likelihood of an event. In other words, it is a likelihood of a subset of the sample space. So probability is, you can say like the likelihood, or you could just say chance. That's an easier word to spell, easier, shorter. The chance of a specific event. And an event is a subset of the sample space. That is how it works. And of course, the probability can be from 0, or between 0 and p, all the way up to 1. It always adds up to 1 or 100%, however you're doing it. Let's move on now. And so when we're talking about a probability model, we're describing an experiment listing all possible outcomes with their probabilities. So a probability model, and again, models are trying to explain reality. This is where we list all possible outcomes with their probability. So let's move to a slightly different example. Let's say I'm flipping a coin. So this is heads, and of course, this is tails, whatever. And so I flipped the coin. And you guys know that there's how it works. So what are my outcomes here? My outcomes are as follows. And this is an equal probability coin. It could be heads or it could be tails. And so the probability is going to be 50% for heads, 1 out of 2, and of course 50% for tails. This right here is a probability model because it describes an experiment listing all possible outcomes with the probability. So my experiment is flipping the coin. That's my experiment. So experiment is flipping the coin. The outcomes can be heads or tails. The sample space is heads or tails. They're often the same a lot of times. You can see that. So on the actual coin, you can see a head or a tail. And so those are the possible outcomes. And then the sample space is heads and tails. And so when we look at that, the actual events here can be heads or tails. We're only flipping it one time. That's what we're trying to figure it out. And so when you add all these up, you can see that when you add 50% plus 50%, you get 100%. And that is pretty much how that works. Now for the die example, it's slightly different because on the dice, you know that we have the 6 sides. You've seen this before. I don't have to draw it again in detail. We have the 6 sides. So now the probability of a 1 is going to be 1 out of 6. Probability of a 2 is going to be 1 out of 6. Excuse me. Probability of a 3 is going to be 1 out of 6. Probability of a 4 is going to be 1 out of 6. Probability of a 5 is going to be 1 out of 6. Probability of 6 is going to be 1 out of 6. That's how that works. And so again, we know that all the outcomes, in other words, the sides on the dice have 1, 2, 3, 4, 5, or 6 on them. The sample space is all the potential outcomes. That's going to be 1 through 6. And the event that we get one number, let's say we roll the dice one time, is going to be 1 out of 6. And there are other ways we can do that. And so this leads me to my next point here. When we're trying to figure out the actual probability of something, we're thinking about the probability of a certain event. That's what E represents. And this is for the assumption that all outcomes are equally likely to happen. It's going to be the number of elements in E, that's in our events right here, over the number of elements in S, or the sample space, if you will, number of elements, just put a quotation marks here, in S, like so. And so that ends up being essentially the number of E over the number of S. So going back to our prior example here, so what is the probability I would get a 1? So the subset that I'm taking from my sample space is a 1. In other words, it's not, well, I shouldn't use the number 1. What is the probability of me getting a 2? Now, how many 2s are on my dice? I mean, there's only 1 2. So my top number is going to be 1. I'm looking for one specific number. I'm looking for the number 2, but the probability of getting a 2 is only 1 because there's only 1 2 in the sample space. And the next question I have to ask is, well, how big is my sample space? Well, my sample space is 6. And that is right there, the probability of getting a 2. Now, if we look at this differently, what is the probability of getting a number that is bigger than 3? So let's see here. You can clearly see that there are 3 numbers bigger than 3. So this time, my event space, or my event, is going to be the number 3. Because there are 3 numbers bigger than the number 3. However, and now the total number of my sample space is still 6. So 3 out of 6, like so. And then this reduces down to 1 out of 2. So there's a 50% chance that when I roll this dice, I will get a number bigger than 3. That is how that works. And so this was kind of an introduction to what's happening with probability and some of the ideas. So I'm going to go back and review what we've talked about and conclude this video. So in this video, we talked about some of the basic terms associated with probability. And we looked at the idea of an experiment. That is when you do something that you can observe and see. So in the example in this video, when we roll the dice, that is an example of an experiment. Outcomes are all the different values that the dice can take. So 1, 2, 3, 4, 5, and 6. The sample space is all of the outcomes together. So again, 1 through 6 is all the outcomes. And an event is a subset of the sample space. I hope you're not confused yet. So for example, I might want to know all the numbers less than 3, all the numbers greater than 4. These are when I take a piece of my sample space, and that is when I can start figuring out the probability for something. So probability is the likelihood of a given event, within a particular sample space, if you will. And so it can go anywhere from, greater than 0 up to the number 1. Or you could say from greater than 0 up to 0.99 if you're using decimals, or from 1, about 0% or whatever to 100%. And so then next we looked at an example of a probability model. And a probability model describes an experiment listing all possible outcomes with their probability. So here I was looking at heads and tails. And so you can see when I flip the coin, that's an example of an experiment. And the outcomes could be head or tails. The sample space is heads and tails. And so you can see here, if I flip the coin one time, there's a 50% chance of heads and a 50% chance of tails. And of course, that adds up to 100%. And then we repeated this process when we are looking at the die. So with the die, we have the 6 sides, and the probability of getting any single number is the number 1. And we looked at the actual formula for that here. And the probability of E is the number of elements in E, which can be one number or several numbers, over the size of the sample space, if you will. And so that's when I made it a little bit more complicated when I said, what is the probability of getting a number greater than 3? So now we have 3 potential numbers. That'll be your numerator. And the denominator is still 6 because 6 is essentially our sample space. And so with some basic math, you reduce it and find out that it's 1 out of 2. So I hope this video was useful for you and that you were able to understand the ideas and concepts that we talked about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.